ions. Ions are nothing but charged species. So what are ionic bonds? So dot and cross diagrams. Now what are dot and cross diagrams? Now let's move on to the ionic bond which is formed between group 1 and group 7. Okay, so diagrammatic representation of how sodium gives its electron to chlorine and how chlorine will possess a negative charge and what type of bonding is between them. Now let's talk about the lattice structure of ionic compounds. Now what are properties of ionic compounds? Now, hello and welcome back, students. So this is going to be your 5th class of chapter number 2, chemistry, elements, compounds and mixtures. In this video, we are going to talk about what are covalent bonds, how are they formed, what are the properties of covalent compounds. In the previous video or the previous class, the class number 4, we discussed about the ionic bonding, how are they formed and what are the properties of ionic compounds. If you have not watched that video, then go, it is a high recommendation from my side, go watch that video and then come back, watch this one. Okay, so let's get started. So what are covalent bonds? Covalent bond is formed by sharing of electrons. Okay, like in ionic bonding, one species would give the electron, another would gain the electron and then ionic bond will form, right? But in covalent bonding, what happens? Two atoms will share 2 or more electrons, and because of this sharing of electrons, a bond is created which is known as covalent bond. Okay, let's quickly read. A covalent bond is formed when a pair of electrons is shared between 2 atoms, leading them to achieve a noble gas electronic configuration. For example, the simplest example to explain covalent bonding is hydrogen. So hydrogen is present like H2. Now, why hydrogen is always present as diatomic molecules? Let's understand, and what type of bond is present between them, right? So, one hydrogen have atomic number what? 1, right? Electronic configuration, if I have to write, then how will I write the electronic configuration? It will be 1. Okay, how many more electrons does it need to completely fill its outermost shell? It needs 1 more electron to complete the doublet, right? So can I write hydrogen and represent its electron with a dot, right? Another hydrogen and let's represent its electron with a cross. Okay, now both of these hydrogen individually have 1 electron each and they need 1 electron each so that their doublet is completed. So what do? They simply share this 1 electron, okay, and complete their octet. For example, this hydrogen have now completed its octet by sharing the electron, and another hydrogen, which is this one, have now completed the octet. Okay, why they have to completed the doublet? Why they have to complete their outermost shell? To achieve the stability or to achieve the noble gas electronic configuration, right? So wherever you share the wherever you see the electrons being shared, there we will form a bond. Okay, so this becomes a bond. If I have to draw H2, I will draw something like this. This is equivalent to H. Okay, so there is a single bond. So this bond represents 2 electrons being shared, right? 1 electron from each hydrogen atom. Okay, so I will just simply put a horizontal line which is also known as a bond, okay, to show that 2 electrons have been shared. Next, now let's move on to the very interesting and important concept that what is the difference between ionic bond and covalent bond. Okay, we always hear this and see that in our books that, you know, they talk about ionic bonding, covalent bonding, but what is the actual difference between both of them, that we are going to discuss today, right? So in ionic bonding, which we have already discussed in your previous video, what is ionic bonding? The bonding between a metal and non-metal, okay, or the bond which is formed between a cation and an anion. Now what is cation? Cation is that ionic species or that charged species which is formed when a metal has donated its electron. Okay, and what is anion? Anion is negatively charged species which is formed when a element or a non-metal has accepted the electron. Okay, so ionic bond occurs between metal and non-metal. This is the first point of difference. And what about covalent bond? Covalent bond occurs between 2 non-metal. Okay, this is a very important and crucial difference point between them, right? For example, H2, which we already discussed, Cl2, F2, Br2, all of them are what? Non-metals. Okay, so the bond which is formed between two non-metal is a covalent bond, and the bond which is formed between a metal and a non-metal is a ionic bond, right? Next point of difference is what? The metal loses electron, because we all know that metals have tendency to lose electron or to donate electron so that it becomes stable. For example, sodium electronic configuration, atomic number is 11, electronic configuration is 2, 8, 1. It donates this one electron to get this electronic configuration 2, 8. This is how it achieves to get a electronic configuration which is equivalent to that of a noble gas, right? And this is how it becomes stable, right? So let's read the second point quickly. The metal loses electron to become a positively charged ion, which is also known as cation, right? Positively charged ion is nothing but cation, while the non-metal gains electron to become a negatively charged ion, which is anion. This is what I told you initially while we just begun with our difference, that a bond between cation and anion is ionic bond, right? These opposite charge attract each other, forming a strong electrostatic force of attraction. Okay, if you have watched our previous video, then you will understand these points in a very good way, right? We have discussed each of these points in elaborative way, right? Next, each atom contributes one or more electron to be shared, creating a stable balance. So in covalent bonding, what is happening? Sharing of electron is taking place, right? But in case of ionic bonding, what is happening? One element is giving electron, another one is taking that. Okay, the shared electrons allow each atom to achieve a full outer shell creating molecule. Okay, like in case of H2, which we discussed in our previous slide, this one. Okay, so this sharing is helping each hydrogen to complete its outer shell. Okay, in this case, they are completing to form a doublet or to satisfy a doublet configuration, right? Next is example NaCl, where sodium donates an electron. I told you sodium electronic configuration is 2, 8, 1. It donates this one electron and becomes what? Na plus, right? And this donated electron is taken by any non-metal. Here we are taking an example of chlorine. So chlorine is 17, 2, 8, 7. It needs one more electron to complete its outermost shell, and hence to achieve stability by completing its outermost shell, right? So it will take this one electron and it will get 2, 8, 8, hence becoming stable, right? So now this chlorine will become Cl minus 1 or chloride or chlorine ion, right? So this is how I can represent ionic bonding, wherein metal is giving electron, donating electron to a non-metal, right? Next, but in case of covalent bonding, what happens? No donation, no gaining, nothing is happening. Only sharing of electrons will occur. Okay. For example, in the case of H2O, so hydrogen and oxygen both are non-metal. Okay. None of them is a metal, right? So the bonding between them, H2O, I can write like this. So the bonding between them, or these bonds, are what? These are covalent bonds, right? Because they are formed between two non-metals. Okay. Now another example is Cl2. So Cl2 is also a diatomic molecule. Okay, chlorine, right? It is a diatomic molecule. Why? Because two chlorine atoms come together. So the electronic configuration is 2, 8, 7. Each one of them needs one more electron. So they simply share one electron from both the sides, and hence they will form a bond between them, single bond. Okay, which shows the sharing of electrons, and this becomes a diatomic molecule because it is stable in diatomic form. Okay, in normal atomic form, like if I write Cl, then it is not stable. Why? Because it has 2, 8, 7 configuration, which is not a stable configuration. For a configuration to be stable, it should be equivalent to that of a noble gas electronic configuration, in which the outermost shell should have completely or should have full electrons, okay, and it should be completely filled, right? And we all know that the first shell, which is closest to the nucleus, have the lowest energy and it can occupy 2 electrons. Then the shell which is after that can occupy 8 electrons, and after that it can occupy 8 electrons, right? So remember this octet rule. Next, in short, I can say ionic bonds transfer electron creating shared ions, but covalent bonds share electrons forming molecules without charges. So I can say that ions are formed when ionic bond is forming, right? There are no charges, no ions present when covalent bonding is taking place, right? So quickly take a minute here and write down the important points from this slide. Now let's move on to next part of this chapter. Very important, types of bond. Okay, so there are three types of bond: single bond, double bond, and triple bond. Okay, single bond is represented like this, double like this, and triple like this. Okay, so each bond is comprised of 2 electrons. So I can say in single bond 2 electrons in total have been shared, or I can say or 1 pair of electrons. Okay, this is equivalent only. 2 electrons in share are in total being shared, or 1 pair of electron is being shared, right? In double bond, I can say that 4 electrons in total have been shared, or I can say 2 pair of electron. 2 pair of electron. Okay, each end of any bond you can understand as an electron. So over here, how many electrons have been shared? 6 electrons. And how many in pair? 3 pair of electrons. Now let's take an example of each type of bonding and when are they formed. In case of single bond, we have already discussed hydrogen-hydrogen bonding. Okay, in that single bond was formed here. Okay, so each hydrogen was giving or contributing 1 electron each, so there is a single bond which is formed between them, right? So you can understand by taking hydrogen-hydrogen bond, or maybe we can also take another example. Let's say hydrogen HCl. Okay, so what happens? Hydrogen have 1 electron in its outermost shell, and how many does chlorine have? So chlorine atomic number is 17, electronic configuration is 2, 8, 7. So let me draw 7 electrons here. How many electrons does chlorine need to fully fill its outermost shell? It needs 1 more. Okay, so it will share the hydrogen electron to complete its octet. So this is how it's gonna get stabilized, right? And how is this hydrogen going to get stable? It will take just 1 electron from chlorine. In total, how many electrons are being shared? Let me change the color. Okay, so 1 and 2, these electrons are being shared, or I can say that 2 electrons have been shared, or 1 pair of electron have been shared. Therefore, there will be 1 bond present between H and Cl, right? So this was your example of single bond. Now let's talk about double bond. So let's take an example of oxygen molecule. Okay, so oxygen have atomic number what? 8. Electronic configuration I can write as 2, 6. Okay, let's represent the electrons 1, 2, 3, 4, 5 and 6. Another oxygen will be having again 6 electrons. I'm drawing the electrons, I'm showing this with cross, okay, so that you know you don't get confused between the electrons. All right, now next, how many electrons does each oxygen needs to complete its fully to complete the shell, the outermost shell? It's need two more electrons, right? So this oxygen is going to take 2 electrons from this second oxygen, okay, and this is going to take these 2 electrons. So in total, how many electrons have been shared now? In total, 1, 2, 3 and 4. So 4 electrons in total, or maybe 2 pair of electrons are shared. All right, so how many bonds will be formed? 2 bonds, right? Because 2 bonds means 4 electron. I told you that consider these ends of the line as electron, right? So this will be correct representation of oxygen molecule. Now let's move on to your triple bonding. So let's take up an example of nitrogen molecule. Okay, N2. So what is the atomic number of nitrogen? It is 7. How do I write the electronic configuration? 2, 5. So now let's represent 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Okay, so how many electrons does it one nitrogen needs to completely fill its outermost shell? It needs 3 more, right? 5 plus 3 makes 8. So it needs 3 more. It will share these 3 electrons. Another nitrogen will also take 3 electrons. Okay, so in total, how many electrons have been shared in case of nitrogen? In total, 1, 2, 3, 4, 5, 6. 6 electrons have been shared. So the bonds will be 3 in number. All right. So this is how I'm going to represent nitrogen molecule. So take a minute here, pause and write down this. Okay, now let's move on. So here we have to form some covalent bond in simple molecules. Let's try one by one. So the first one is water, okay, H2O. So in this, two type of atom is present, oxygen and hydrogen. So oxygen have how many electrons in its outermost shell? Oxygen atomic number is 8, okay, and electronic configuration will be what? 2, 6. So let me draw 6 electrons, 1, 2, 3, 4, 5 and 6, okay. And how many hydrogen is present? 2, right? So each hydrogen will have 1 electron, right? Oxygen need 2 more electrons to completely fill its octet. So it will take these 2 electrons. Hydrogen needs 1 more. So here, how many have been shared? So 1, 2. So I can draw it like this, and 1, 2. So this becomes the proper representation. Okay, now the electrons which are not being shared in formation of covalent bonding, or the electrons which are not involved in the formation of covalent bonding, actually makes the lone pair. Okay, so these are known as lone pair. Here we can see there are 2 lone pair present. Okay, 2 lone pair, right? Next, let's talk about CH4, which is methane. In this, I can see carbon atom which is bonded with 4 hydrogen atoms, right? So carbon atom, what is the atomic number of carbon? It is 6. Electronic configuration is 2, 4, right? So 4 electrons are present in the outermost shell. Okay, this is how I will represent. Now, how many hydrogen is there? 4. So 1, which will bring its 1 electron, another one, and the 4th one. Okay, now each hydrogen needs just 1 electron, and the carbon needs how many? 4. Okay, because 4 it already has, and now it needs 4 more. So it will take these 4 electrons to complete its octet. Hydrogen needs 1 electron to complete the doublet. So this is how they are going to share. Now see, 1, 2 electron being shared between carbon and hydrogen, each hydrogen. So I can draw it like this, right? This is how we will represent the formation of bond. Okay, wherever you see the bonds being shared or the electrons being shared, there you will just put 1 electron. Simple. Next, let's talk about the third one, which is NH3, ammonia. Now, how will we form bonds in ammonia? So nitrogen atomic number is 7, electronic configuration is 2, 5. So let me draw 5, 1, 2, 3, 4 and 5. These are 5 electrons of nitrogen, right? How many hydrogens are connected with it? 3. So each hydrogen one with its 1 electron. Okay, now the sharing. Let's talk about the sharing. How many electron does nitrogen need to complete its outermost shell? It needs 3 more. Okay, it already has 5, it needs 3 more, so that it becomes 2, 8, which is a stable electronic configuration, right? So it will take these 3 electrons of hydrogen and it will share 1 electron each with each hydrogen atom. This is how hydrogen also gets stabilized and nitrogen also get stabilized. So each will have 1 bond. So can I write it like this? Correct? This is how I will represent. And the electrons which are not involved in the formation of covalent bond, these are known as what? I told you this is lone pair, right? This is called lone pair. Now quickly note this thing down. Now let's move on. Okay, so few more. The first one is methanol. Okay, this is methanol. So in this we can see 3 type of atoms present. Which one? Carbon, oxygen and hydrogen, right? So carbon we have discussed 4 electron in its outermost shell. Okay, oxygen have how many? Oxygen electronic configuration is 2, 6. So I will draw 6 electron, 1, 2, 3, 4 and 5, 6. Okay, Then let's talk about hydrogen. So one hydrogen, okay, one hydrogen near oxygen. Okay, hydrogen. Okay, next one hydrogen here, another one here. Right, now let's see how the sharing is going to occur. So each hydrogen needs one electron to complete its doublet. This is how it's going to share, right? Next, carbon needs 8. So it will take 3 electrons of 3 hydrogen each and 1 electron from oxygen, right? So there will be a bonding between oxygen and carbon, oxygen and hydrogen, sorry, carbon and hydrogen, and carbon and hydrogen, okay? Then how many electron does oxygen needs? The electron, the number of electrons which are present in its valence shell is 6. So it needs 2 more electron. One it will take from carbon, another one it will take from hydrogen, okay? So like this, right? So let's draw. So carbon is sharing each electron with hydrogen. Then 1 electron is being shared here with oxygen, and then oxygen shares with hydrogen. So this becomes a proper representation of how bonds are formed in methanol, right? Next, let's take another one, which is carbon dioxide, CO2. So each carbon have, we know it is 6, 2, 4 is the electronic configuration, 1, 2, 3 and 4, 4 electrons of carbon, right? And it is bonded with how many oxygen? 2 oxygen. Each oxygen have how many electrons? Oxygen is 8, 2, 6. So let's draw 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. Okay. So now let's talk about the sharing. Carbon needs 8 more. So 4 it has. 2 each it will take from 2 oxygen atom, right? 8 completed. Oxygen needs 2 more. So it will take 2 electron from carbon, and this is how it's going to share the electron, right? Now let's check how the bonds will be formed. Can you see these electrons being shared between oxygen and carbon? So how many electrons in total? 1, 2, 3, 4. So 4 electrons have been shared, or 2 pair of electrons. Therefore, I will make 2 bonds between carbon and oxygen. Similarly, here also how many bonds will be formed? 2 bonds. Why? Because 4 electrons in total have been shared, or 2 pair of electrons have been shared. So this is going to be the proper representation of how covalent bonding will be formed between carbon dioxide. Next is your ethene molecule. Okay. So this is what? Ethene. So 2 carbon, each having its 4 electrons, right? 4 electrons each carbon is having, and then they are bonded with 2 hydrogen each. So 1, 2, 3 and 4. Now let's talk about the sharing. Each hydrogen needs 1 more electron to complete its doublet. Okay. So this is how they will complete their doublet. What about carbon? Each carbon needs 4 more electron. So 2 it will take from 2 hydrogen, and 2 it will take from this carbon. Got it? And similar thing for this one also. So now let's make bonds. Carbon and carbon, how many electrons have been shared? 1, 2, 3, 4. So 2 bonds will be formed between carbon, because in total 4 electrons have been shared. Which 4? 1, 2, 3, 4. Okay, and then each carbon hydrogen bond have single bond. Why? Because they are sharing 2 electrons only. This one, 1, 2, 1, 2, 1, 2 and 1, 2. Right? So take a minute here, draw these. Now let's talk about properties of simple molecular compound. Okay, in your previous class we discussed about the properties of ionic compound, in which I told you that the ionic compound have strong electrostatic force of attraction between them, and because of that it has high melting point and high boiling point. Okay, but in case of covalent bonding, or in case of compound which have covalent bonding in them, they have low melting point and low boiling point. Why? Because they have weak intermolecular forces between them, right? If you can see this diagram, this is a covalent bond, okay, or a covalent compound, HBr, hydrogen bromide. Okay, but 2 covalent compound molecules have what type of bonding in between them? they have weak intermolecular forces. Therefore, we need to provide only little amount of heat to break these bonds down, right? Therefore, the melting point and the boiling point of covalent compounds is less, right? And they are usually found in gases and liquid states of matter. Why? Because of the weak intermolecular bonding, they do not come closer to each other and form a solid-like structure. Got it? So they are found in gases or liquid state at room temperature. Next, we talk about another property of compounds, okay, covalent compounds. What? Poor electrical conductivity. So when we discussed in ionic compounds, what did I tell you? That the electrical conductivity of ionic compound is good. Okay, they show good electrical conductivity. Why? Because they have ions present in them. Okay, one thing we have to note down is that ionic compounds in solid state cannot conduct electricity. We have to either dissolve them or melt them so that they conduct electricity. Okay, but in case of covalent compounds or the simple molecular compounds, they do not show conductivity or electrical conductivity. Rather, they are electrical insulators. Why? Because they do not have ions which can move and hence they can conduct electricity, right? So they are insulators, they do not conduct electricity. These compounds are typically do not conduct electricity because there are no free moving electrons. Okay, so for electricity to be conducted, either of the two things should be present. Either they like the compound should have free moving ions or free moving electrons, right? But the simple molecular compound or the covalent compound do not have either of these. All right, so that is why they cannot conduct electricity. Therefore, simple molecular compound do not conduct electricity in either their solid or liquid state. They are typically electrical insulators. So these are the two important properties of covalent compound which you should know, that they have low melting and boiling point. Why? Because they have weak intermolecular force between them. Okay, then they do not show electrical conductivity. Why? Because they do not have free moving ions, right? Next is a question which I have for you. So they are saying methane is the simplest hydrocarbon and has formula CH4. We have already discussed methane. What is the total number of electrons involved in the bonding in methane? All right, so methane, CH4, they are talking about carbon and hydrogen. So carbon atomic number is 6, hydrogen is 1, electronic configuration is 2, 4. Okay, so how will I draw? Carbon 1, 2, 3, 4. It has 4 electrons in its outermost shell. It needs 4 more, okay, to get stabilized. Hence, it will react with how many, or it will bond with how many hydrogen? 4 hydrogen. Okay, so each hydrogen will contribute 1 electron in the sharing, and hence the sharing will look something like this. So carbon completed its octet, right? Each hydrogen also completed its doublet. Okay, both of these atoms have achieved noble gas electronic configuration, right? How will I draw the bonds? See, then single bond between carbon and hydrogen. Why? Because only 2 electrons have been shared. So 2 electrons mean one pair of electron. So this will look something like this. So in total, how many electrons do you see being shared? So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, in total 8 electrons have been shared. You can do it this way, okay, or you can check this way also. How? Okay, so each bond represents 2 electrons, right? How many bonds can you see? 1, 2, 3, 4. 4 electrons, 4 bonds in total we can see. Each bond comprises of 2 electrons. Therefore, 2 times 4 or 2 multiplied by 4 becomes 8. So in total 8 electrons have been shared. Okay, so each bond is comprised of 2 shared pair of electrons, 1 from carbon, 1 from hydrogen. Hence my answer becomes 8, which is C. Okay, I hope this is clear. So this is where we come to an end of this video of your class 5th of chapter 2, elements, compounds and mixtures. In this class or this video, we discussed what are covalent bonds, how are they formed, how they are different from ionic bonds, and what are the properties of covalent compounds. I hope this has been helpful for you to understand the concepts. If yes, then please show your appreciation and put a like. And if you have any doubt, you can write in the comment section. I will get back to you. And if you feel like sharing it with your friends, then please do so. Also subscribe to our channel. Till then, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.